All right, today's notes we're taking are on systems of equations. So I have this first section just filled in really quickly. I'm going to just go over a few key points before I do some examples. So systems of equations is the current unit we're looking at, and it's going to be furthering our knowledge from just normal linear equations and linear inequalities. So a definition is two or more equations with the same variable. So rather than just having one single linear equation or one equation, it will consist of two or more. For the most part this year, we will just be using two. So today, we're going to find the solution to a system graphically. And to do that, the points x, y, where two lines intersect, and we'll see that in our examples. And then algebraically is we will be able to prove that when the point x, y, that makes both equations true. So again, we'll look at both of those in an example, but just so you have that definition written down. There are three types of solutions. The first type is intersecting lines, and when we have intersecting lines, we have one solution. So that means those lines are only going to cross at one point. If we have parallel lines, these lines will never cross, and that will result in no solution. And the third one is where the two lines are the exact same, meaning they have the same slope, same y-intercept, and they will cross over each other, which results in infinite solutions. So, to solve a system of equations by graphing, these are your three steps that I will refer back to. The first is to rewrite the equations in slope-intercept form, and just a reminder, that is the y equals mx plus b. So sometimes they'll give it to you in standard form or in point-slope form, and you'll have to be able to transfer it to y equals mx plus b. The second step is to graph the line, which we've been doing for a long time now. And the third is to identify the solution or solutions based on the example. So I'm going to switch over and we're going to work some examples together. So the first one we're looking at is y equals x minus 8 and y equals negative 2x plus 1. So each of these equations is already in y equals mx plus b. So in this case, we just get to skip to the second step, and we start by plotting our y-intercept. And so I'm going to go ahead and count down 1, 2, 3, 4, 5, 6, 7, 8. And then I will put a dot there. And then our slope is going to be 1. So that means I'm going to have a rise of 1 and a run of 1. So then from my y-intercept of negative 8, I'm going to count up 1 and then over 1, up 1 over 1, up 1 over 1, and so forth. And so this will be the line, my first. Let me see if I can make that a little more straight. Let's see. All right, so that's our first line. And then the second line here, we have y equals negative 2x plus 1. So we have our y-intercept of positive 1, and we have our slope of negative 2. So if my m is negative 2, my rise is going to be negative 2, and my run is going to be 1. So I'm going to go up 2 and to the left 1, or I can also go down 2 from my y-intercept and to the right 1 to continue my line that way. Move this line over a little bit. Maybe. side. There we go. It's a little better. So now, as we see here, we have our line that's going through these points. So now we have our two lines graphed, and we see that they intersect. I'm going to highlight. So where that dot is, that pink dot, that's where the two lines intersect. And that is the solution to the system. So where that pink dot is right there, we need to identify the XY coordinate pair. So we look here at positive 1, 2, 3 on the X and negative 1, 2, 3, 4, 5. Negative 5. So that right there is the solution to that set. All right. So let's go ahead and skip to a more difficult one maybe. Let's go ahead and do number 3. So on these two, we don't have them in y-intercept form, so we're going to have to solve these ones for, so negative 3x plus y is equal to 8. So to get y by itself, we'll have to add 3x to both sides. Then we have y is equal to, I'm going to switch this over here, so it's a 3x plus 8. So that's the first one. And the second one, we have negative x plus y is equal to negative 2. And this one's pretty easy. We're just going to add x to both sides, and then I'm going to rewrite it in the correct order. So my two equations are just highlighted in pink. So now we need to graph these. So the first one, we'll have a y-intercept of 8. So I'm going to count up to 8. And then I have a slope of 3. So again, that slope of 3 is going to be a rise of 3 and a run of 1. So since I can't, in this instance, from my y-intercept here, I can't go up 3 anymore, but I can go down 1, 2, 3. And since I need to keep my graph positive, I'll go down 3 and then to the left 1, keeping my overall line overall line positive. And this would be a lot easier if you're in class. On paper, you can use a ruler. But let me go ahead and draw that line. All right, and the second one we have is x minus 2. So that means our y-intercept is going to be a negative 2, and our slope is going to be up 1 over 1, up 1 over 1, up 1 over 1. I'm going to also go in this negative direction since I don't have a ruler right now. So I see that these lines, I need to intersect. Again, I'm going to go ahead and highlight that intersection point in pink. And so off to the side, our solution is where these two lines cross, and that is negative 1, 2, 3, 4, 5. So we have x is negative 5, and y is 1, 2, 3, 4, 5, 6, 7. And our y is negative 7. So that there is how you would solve, so problems 1 and 3, how you would solve a system of equation graphically. And then looking back at these answer choices, we're going to just make this proof before we end. Algebraically, the point xy makes both equations true. So what we mean by that is this point that we found down here, 3, -5. When I substitute this xy coordinate pair into either equation, so the first one is y is equal to x minus 8. So we're taking the y of -5 is equal to the x, which is 3 minus 8. And when I say -5 is equal to 3 minus 8, which is also -5, and that is a true statement. So it worked on the first one. So now we need to make sure that algebraically it checks out on the second one. So our second equation was y equals -2x plus 1. And then we're going to do that substitution again. So -5 is equal to -2 times 3 plus 1. So now we have -5 is equal to -6 plus 1, and -6 plus 1 is also -5. So we know that we found the correct point because in both instances, right here and right here, the solution that we found worked out algebraically and graphically. So I'm going to go ahead and check that second one that we did together. And in this case, the solution that we found, -5, -7, our x being -5 and our y being -7, we could substitute these numbers into this form, into the standard form or the slope-intercept form. But since we've already transferred them, we'll just go ahead and substitute as follows. I'm going to erase this. So the first one we have -7 is equal to 3 times -5 plus 8. So -5 is -15, so -7 is equal to -15 plus 8, which is -7. So we have that one that checks out. And then on the second one, we have -7 is equal to -5 plus, -5 minus 2, so -7 is equal to -7. So in both of these cases, both of the equations that we found checked out algebraically and graphically, so we know that we did both of those correctly. And now there are just some other problems that you could work out, and just make sure that you're rearranging your equations properly. And then remembering, like on number 5, we have these special cases, like y is equal to -7. Remembering that this is a horizontal line because we have no slope. We only have a y-intercept that provides our line. So being something like this, a line at -7, that would be 1. And then remembering what an equation like this one down here at number 8, the x is equal to -2. So remembering the difference between those two lines before you find your solutions.